Okay, moving on to 6.7, the imaginary number. So why do we have the imaginary number? Well, throughout the history of mathematics, new numbers have been invented so that we can solve difficult word problems or difficult problems. So in the past, we might have said some number plus 3 has to equal 2. How can we decrease that value, make it equal to 2, instead of increasing it and only adding positive numbers? So they created the integer to try to figure that out, right? So -1 plus 3, so they created the integers. So now, well, how can we deal with a not real situation? Well, they create the imaginary number. So here is the definition of the imaginary number. I represents an imaginary number. What does I equal? I equals the square root of a -1. So therefore, if we square it, I squared will equal -1, right? If 4 equals the square root of 16, then 4 squared equals 16. So if I equals the square root of -1, then I squared equals -1. Right, so you can see that relationship there. So when you're looking at a question like the square root of -7, you can think of it as taking the square root of -1 times the square root of 7. But the square root of the square root of -1 as defined by the imaginary number just equals I. So the square root of -7 simplifies to become I root 7. The square root of -32, well, if you want to, you can write it as the square root of -1, and then 32 has 16 times 2. So if I factor out, or if I take out the -1, then I have the two numbers here are going to be positive. So now the square root of -1 is I, the square root of 16 is 4, and the square root of 2 is irrational, so you keep it as radical 2. So my simplified answer is 4I root 2. Okay, let's look at letter C. Find the reciprocal of I. So the reciprocal means you put 1 over it. But guess what? You're not allowed to have I in your denominator. So you have to multiply the top and bottom by I, because we see up here, if we multiply I by itself, we get I squared. And I squared is an integer, it's -1. So we multiply by I over I. So 1 times I is 1I. And then I times I is I squared. But what is I squared? I squared is -1. So guess what the reciprocal of I is? It happens to be -I. So the reciprocal of I is -I. Okay, moving on. So letter C. Notice the minus sign here. So we're taking the square root of -6 minus the square root of -24. So the square root of -6, you can break that down to square root of -1 times square root of 6, which becomes I root 6. You don't need to do this step anymore if you can do it mentally, right? So the square root of -6 is I root 6. The square root of -24, well, I can take out my -1, so that becomes I, and the square root of 4 is 2, so that's 2I root 6. I usually put that number in front, right? So it's 2I root 6. And then these are like terms. They both have they both have an I root 6. So remember the coefficient here is 1, so 1I root 6 minus 2I root 6 is -1I root 6. Right, so 1I minus 2I here gives me -1I here. Okay, how about letter D? 2I root 3, that quantity squared. I think it's going to be best if you write it out twice. 2 times 2 is 4, I times I is I squared, and root 3 times root 3 is just itself, or square root of 9. Right, so root 3 times root 3 is root 9, but the square root of 9 is 3. So we have 4 times I squared times 3. Well, I squared is equal to -1. So this answer is equal to -12. Okay, now let's look at letter E. Letter E, you cannot simplify this by putting it, if they're negative numbers, you cannot do the shortcut where you put it back under the same radical. Okay, you cannot do that because this is defined as being the square root of -1 times the square root of 3, which is I root 3. And this is defined as being -1, the square root of -1 times the square root of 27. Because really, you can't take the square root of -27. So we can't go back and multiply them together and make it a positive 54 because then we're ignoring the fact that we're going to have an I for both of them. And I times I is I squared, which is a -1. So we have an I squared 3 times 27, right? So that's I squared, and then 27 is 3 times 3 times 3, or 3 times 21 is, or sorry, 3 times 27 is 81, or you can see here that we have a couple of pairs of 3's, and for every pair we take them outside. So I squared is equal to -1, the square root of 3 squared is equal to 3, and the square root of 3 squared is equal to 3. So this overall answer should be -9, not +9. Where if I continued up here, -3 times -27 would have been +81, which would have given us a +9, but that is not what this answer is. The final answer is -9, not +9. So you cannot go back and do the rule. When you have negative numbers, you cannot go back and put them underneath. You need to treat them individually so you can pull out the i's, because they're imaginary to begin with. Okay, if you have a question about that, you can ask me in the future when I see you next class. Okay, letter F. You cannot have an I in the denominator, so we need to multiply by an I. Do we need to multiply by the 7? No, I was just about to make it a lot harder for myself. The only thing that's illegally in the denominator is this letter I. So I really just need to multiply by I over I. So in my numerator I get a 3I. In my denominator I get 7 times I squared. Well, I squared is equal to -1, so that becomes 3I over -7, or just -3I over 7, right? These are the same. So that would have been 3I over 7I squared, but I squared is equal to -1, so you get -7 in the denominator. Okay, for letter G, if at any time you want to try these on your own, I would pause, right? You should pause, try it on your own, then check your answer. Okay, so 32, well, I'm going to make that positive by taking out the -1. The square root of -1 is I, so that becomes I root 32. Okay, how can I make the square root of 32 a perfect square? Okay, well, first of all, I have to get rid of my I in the denominator, so I've got to multiply by I. Well, 32 times 2 will give me 64, and 64 is a perfect square. So I'm not going to multiply by the square root of 32, because that's going to be a huge number that I'm going to end up canceling. So if I just recognize that 32 times 2 is 64, then I'm going to have a perfect square down here in the denominator. So 32 times 2, 64, the square root of that is 8, and then I times I is I squared, so that became a -8 in my denominator. What do I have in my numerator? I have 15I root 2. Can I cancel anything here with the 15 and the 8? These are the numbers on the outside of the radical. They're not divisible by the same number, so my answer is just literally 15I root 2 over -8. Next one, letter H. Okay, letter H, you might want to simplify first, right? So we can take an I and put it root 18, and then in my denominator, I root 12. Now these are both positive, and they're both underneath the square root sign, so I can simplify them both by 3 if I want to. I don't know if that's going to help, but it might. So they're both divisible by 3, so this becomes root 6, and this becomes a root 4. Okay, now notice I pulled the I out of both of them, so what happens to my i's? They can cancel each other out. Oh, that did help me, right? So they're both divisible by 3, so this gave me a square root of 4. So I end up with 4 root 6 over 2, because the square root of 4 is 2. But then 4 and 2 are both on the outside of the radical, so that means I can cancel further. 4 divided by 2 is 2. So this final answer is just simply 2 root 6. And I did that really quick and easy. How might you have done it? You might have done 4 the square root of negative 1 times square root of 9 square root of 2 for my numerator. This would have been square root of negative 1 times square root of 4 times square root of 3 in my denominator. So to simplify that, I would have had square root of negative 1 is I, square root of 9 is 3. So I would have had 12I root 2 over 2I root 3. Multiply the top and bottom by root 3. Simplify this stuff out here. So I would have had 12I root 6 over 6I. If I didn't simplify, I just kept multiplying it out. And then 12I divided by 6I is just 2, so my final answer would have been 2 root 6. Okay, letter J. Assume J and K, assume that each variable represents a positive real number. Okay, so x's are positive, r's are positive. So we have to take out our I, and then we have the square root of 9x squared, and then we take out our I, we have the square root of x squared. So we get I times 3x plus I times x. So we get 4xi because they are like terms. So my final answer is 4xi. For letter K, we're going to take the square root. Sorry, it's a negative, so that becomes I times the square root of 4r squared root r. I'm trying to break this down into my perfect square, my non-perfect square. So 4r squared times r is 4r cubed. I have a negative underneath the radical, so I'm going to take out my negative by taking an I outside, right, because that's the square root of negative 1. And then I have 64r squared times root r. And then minus 4r, I'm going to take out an I because of the negative sign. And then I have the square root of 16 is my perfect square, r is my non-perfect square. Right, so what is the square root of 4r squared? That's 2r. Square root of 84r squared, that's 8r. Square root of 16, that's 4. So now I'm going to go back and I'm going to multiply I times 2r, so I get 2ir, and then I have to bring down my root r. And then here I'm going to multiply I times 8r, which is 8ir. I'm going to multiply that by root r. And then my final one, I have 4r I times 4, which is 16ir, and then root r. So they all have i's, so 2ir plus 8ir minus 16ir, and they all have root r. So they are completely like terms, so we can combine them. So it's 2 plus 8 minus 16. Well, this is 10. 10 minus 16 is negative 6. And so this is my final answer. And it could be negative 6ri root r. So there you have it. Final 2, we're going to solve for x. How do you solve for x? First, you move the positive 25 to the other side, so we get negative 48. Then you divide each side by 4, so x squared equals negative 12. Before, we used to say we could not go any further. Now we can. What do? We take the square root of both sides. But when you take the square root of both sides, remember this says we need to have 2 answers. So my answers are positive or negative. So root 12 becomes root negative 4 times root 3. Well, the square root of negative 4 is 2i. So I get x equals plus or minus 2i root 3. I have 30 seconds left, so I'm going to do this last one quickly. 3x squared equals negative 18. X squared equals negative 6. Take the square root of both sides. So x equals plus or minus I root 6. Let me check it because I did that super fast, which means I might have an error. So 5 minus 23 is negative 18. Divide each side by 3, I get negative 6. When I take the square root, I have to take an I out. 6 is not a perfect square. It doesn't have a perfect square factor. Remember, it has to be 2 solutions, which is where I get my plus or minus. So yes, that looks correct to me. There's our 15 minutes. The time is up. Good luck. See you soon.